Okay, so in this chapter we're going to look at ways to solve oblique triangles, and oblique triangles are any kind of triangles, not just triangles with a right angle. And so our first method that we're going to use is going to involve the law of sines here. And like I said again, what's nice about this is it works in any triangle at all. But if you notice, you're going to be able to set up a proportion. So this is probably, this is a very easy formula to use. So we're just setting up a proportion. But notice though, in order for this to work, you have to have an opposite ratio. So for example, if you know the measure of side A and you know the measure of the angle opposite that side, then you have a ratio that you can use then to set up a proportion. And if you're just given either another side length or another angle measure, then you can set up a proportion to solve it. So, but you do have to have an opposite relationship there. So like an angle and a side opposite each other. Alright, so for example, in this first problem, notice that I have angle B given, and then I also have the side opposite that angle given. So I can use the law of sines here. I will take the length of side B, so 27.4, and put it over the sine of the angle opposite that side, so over the sine of 28.7 degrees. And I will set that equal to, because I have given the measure of angle C, so then in the denominator, on the other side of the proportion, I'm going to put the sine of 102.3, and then in the numerator then, I need to put side C. Okay, so that's how that works. So now we have a proportion, and we're only missing one variable in that proportion, so now we can cross multiply. Okay, so go ahead and cross multiply and see what you come up with. Okay, so after you cross multiply, hopefully you will agree that side C is equal to 55. I got 75 feet, 55.75 feet. Okay. Actually, though, when we solve a triangle, that means we have to find all the missing information. So I also need to find the measure of angle A and the length of side A. All right. Well, to get angle A, because I know two of the angles, I'm going to add those together and then take it from 180. So you will find then that angle A is 49 degrees. And now I also have to find the length of side A. So then we can set up another proportion. I would go ahead and use...
Jessica Grable, please call Miss Buckley's desk, 8110. Jessica Grable, please call Miss Buckley's desk. Thank you.
All right, so did you guys get that information? Sorry about that. Okay, so I'm going to use that information that we started off with, where we had side B and the angle opposite that, so I'm going to keep that. But this time, I'm going to set it equal to, I'm looking for side A, and I just found that the measure of angle A was 49. So I'm going to put side A over the sine of 49. Alright, so now you're going to use that proportion and solve it for A. And if you do that, then you should come up that A is equal to 43.06 feet. Okay, So there's an example. Now let's take another one here. This time, you would have to, I already have the triangle drawn for you, but a lot of times you would have to go ahead and draw your own triangle. So it says we have a pole that tilts towards the sun at 8 degrees from the vertical. Okay, so this is my pole right here. And it's not quite putting the ground straight. It says it's 8 degrees from the vertical. So that means then that the measure of this angle is 98 degrees. Okay, so I have given that angle. It casts a shadow 22 feet long. So then this would be the shadow, this side down here. The angle that should be an of elevation. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So this angle here is 43 degrees. How tall is the pole? Okay, so we're looking for this length right here. Okay, well, I need to have an opposite relationship. So I have 98 degrees, but I don't know the length of the side opposite it. I have 43 degrees, but I don't know the side opposite it. That's where the X is. And then I have a side 22, but I don't have the angle. Well, right now I don't have the angle, but we can find it. So if I know the other two angles, I can add them together and subtract it from 180. So when you do that, you should come up with the measure of this angle here to be 39 degrees. So now that I have that angle, I can take the 39 degrees and then the side opposite it, which is 22. So I'm going to go 22 over the sine of 39 is equal to, and then I want to find the height of the pole, so that's x, over the angle opposite that side, so over the sine of 43. Okay. So this one doesn't ask us to solve the triangle, we just need to find that one length. So when you cross multiply then, you should get x is equal to 23.84. Okay, so verify that. Make sure your calculator is in degree mode and try it out. Okay, so let's take a look at this one. So here we have two sides and the non-included angle. So here are the two sides, right here, and then here's this one here. And this angle is not in between those. So in geometry, we refer to that as the side-side angle. Now, in this case, sometimes you'll have a solution and sometimes you won't, and sometimes you'll have two solutions. So this one is one where you just have one solution. So notice that we do have an opposite relationship. So then we are ready to set up the proportion. So we have, on this one I'm going to do it upside down. This is the way I learned it. I learned it that it's the sine of the angle over the side opposite. So sine of 42 over 22 is equal to the sine of B, because I'm given side B, which is 12. So in the numerator then, I need the sine of the angle opposite that side. So the sine of angle B. All right, so there's our proportion. Cross multiply, and this one I will show you though, because this one we were looking for an angle, so actually let's write this out. So if I have 12 times the sine of 42, and that is equal to 22 times the sine of B. And because we're looking for the angle, we have to use some of those things that we learned about in the last chapter. to solve for an angle. Alright, so on the left side, if I plug it into my calculator, I get 12 times the sine of 42, and I get 8.03. So I am not going to clear that out of my calculator. I will round it when I write it down for you here. But we don't want to do any rounding or anything until we were all the way done. So you keep that whole thing in your calculator. And now we want to solve for b. So what I need to do first of all is get rid of the 22. So we divide by the 22. And now that 8.3 turns into 0.3649. I'll just put 0.34365. But here again, I'm not changing anything in my calculator. But the sine of the angle is equal to that decimal. So to solve for b then, the opposite of taking the sine is the inverse sine. So we go second sine, second answer, and we get 21.4. So that's the measure of angle B. Okay. And then if you needed to go ahead and solve the triangle, then you could finish that up. Find angle C by subtracting the two measures that we know and go from there. We'll just stop here on that one. Alright, so sometimes you have to solve for the angle. Sometimes you're solving for the side. But either way, you can still use that same formula. Okay, so now let's take a look at this one. So notice again here, I don't have a figure drawn here, but I have side A and I have angle A. So those two are opposite each other. So I'm going to put the sine of 85 over the side opposite that angle. So that'll be over 15 is equal to, I want to find angle B first of all, since I'm given side B. So the 25 goes in the denominator because that's where I have the side length on the other side, over the sine of angle B. Okay, so I'm going to cross multiply then. We're looking for angle B. So we're going to take 25 times the sine of 85, and that's going to give us 24.9. So 24.9 is equal to 15 times the sine of B. So we want to solve for B, so I'm going to get rid of the 15 first. So we divide both sides by 15. So then answer divided by 15 is 1.66. So now I know that the sine of B is equal to 1.66. Now we have to find the angle that has that sine. Well, maybe some of you remember that our sines just range between 1 and -1. So it's like, oh, how can we get a sine of 1.66? Well, let's try it on the calculator. So go second sine, second answer, and then what happens on your calculator? You get an error. And once again, it's because we can't have a sine that big. So if you get an error, that means it's not possible. So I cannot solve this equation. So no triangle is possible. So we don't have a solution. And so the way you're going to do that then is just go ahead and set up your ratio, and if you get an error then, or if you get to a point like this where you have the sine of the angle is equal to a number outside of the range, 1 to -1, you know that it's not going to work out. Okay? To solution case. So here again I have side A and angle A. So I told you in class that I want you to draw this out so that angle A is in the lower left-hand corner. So I'm going to draw it right here. So this is A, and the measure of A is 20.5. So the side opposite is side A, and so this length here is going to be 12. And then for the other side that's given, I want you to put it up over here on the left-hand side. So this side here will be 31. Okay? So we have that opposite relationship, so we set up a trig ratio. And notice in that last one I put the angle on top, or you can put the side. It really doesn't matter. Let's go ahead and do this one like they have in the book. So we want side A over the sine of 20.5. And then on the other side, oh, that's kind of ugly, is equal to, and we have 31, so the side length is 31, and we're looking for the angle opposite it. So we said that was 31 was side B, so this angle then is angle B. So we'll put the sine of B down below the 31. Alright, so now we're going to cross multiply. So I've got 31, and I don't think I'll write down the 31 times the sine of 20.5. So let's just go ahead and multiply it, and then we'll write down what we get for that decimal. So I ended up with 10.86. So 10.86 is equal to 12 times the sine of B. So we divide by the 12. Now I get a number between 1 and -1, so this is looking more promising. So we need an angle that has 0.9 for its sine. So now we do inverse sine or arc sine. So second sine, our answer, second answer. And so for angle B, I get 64.7. Okay? Well, actually 0.8. All right, so that then is going to give, that's the beginning of our first solution. So I'm not going to have room at all on here to go ahead and solve that. So you would have to then take that, say now we have angle A, we have angle B, so then you would find the measure of angle C, and then you would also find the length of side C. Okay? So you're going to get angle C by subtracting the two angles that we have from 180, and then you set up the law of sines again. So that is going to give us our one solution, our first solution. But on this one, we have a second solution. So remember on here, because this side length, this 12, if I swing it, remember how this is kind of the hinge up here? So if I swing this side and I swing it back over this way, then I could also have this triangle right here. Alright, so now let me draw in the rest of it. So now it is possible to have an angle of 20.5, a side length of 12, and this other side still of 31, but the triangle looks like this one. Okay, so what we have to do is find that other solution. Well, we started off the same way, and we find out, you're going to set it up exactly the way we did this, and you're going to go through all of this work where you're not magically going to get a different angle. The calculator is still going to give you that same angle, but remember that was the measure of this angle here. And because if we look at our little drawing, this side and this side are the same length, they're both 12, so that means we have an isosceles triangle, and your base angles are the same in an isosceles triangle. So that means that angle right there that I just drew in is also 64.8. But what I need is the measure of this angle. Well, how am I going to get that angle? How are we going to get that green angle? Well, we use the fact that this angle here and this one they form a linear pair, so they are supplementary angles. So to get our new angle B, which we refer to as B prime for our second solution, by taking 180 minus the 64.8. And when you subtract that off then, obviously we're going to have an obtuse angle. So the measure of angle B in our second solution would be 115.2. Alright, so that then is going to give you a different measure for angle C. So now you're going to add the 115.2 to the 20.5 and take it from 180, and that'll give you a new measure for angle C. So notice this angle up here, C, is different than the C in our first triangle. Okay, so that one's going to be smaller, and then you're going to have a different side length, C. Okay, and when you set up the law of sines, then you'll figure out what this new C is, because our old C went from here all the way over to here. So those are your two solutions. So you need to finish that up because I'm not going to be able to fit it all on this screen. Okay, and we can talk about that more in class if that's kind of confusing. Okay, and then the last thing we're going to do is just apply this formula for finding the area of an oblique triangle. So we already have a formula for finding an area of a triangle, which is just area is equal to 1/2 base times height. Well, that only works if you know the base of a triangle and then base times height. What did they put? C, 1/2 base times height. But this one will give you the area of a triangle. Notice, let's take a look at this one here. So area is equal to 1/2 BC sine A. So if I draw a little triangle, it says that you're given two sides, so B and C. So let's say that this is B and this is C. So then up here is angle C, over here is angle B, so that means this angle here is angle A. So in order to use this one, you're given two sides, this side and this side, and the included angle, Okay, so it says find the area of a triangular lot having two sides of length 90 and 52 meters and an included angle of 102. Alright, so let's draw our triangle. So here's our included angle. So this is 102. And then we'll let this side here be the 90, and then this other side be the 52. So we're given two sides in the included angle. So then we can use the formula that says to get the area then, you take 1/2 the product of those two sides, so 52 times 90 times the sine of the included angle, and our included angle is 102 degrees. So to get the area, I just need to substitute this whole thing, put it right into the calculator. Once again, make sure you're in degree mode though, because that angle is in degrees. So I need 0.5 times 52 times 90 times the sine of 102. Plug it all in, and I get 2,288.9. So that's the area, and because It gave us the length was in meters. This is square meters in for the area. Okay. So good luck with the law of sines. It actually is a fairly simple formula to use, and then this other formula for finding the area of a triangle is pretty simple also. All right.